Let's learn C. This is a program for beginners, and we're going to go through the C language and really understand each of the components. In today's lesson, we're going to focus on floating point precision. It's not quite intuitive. Sometimes things happen that you just wouldn't expect. So we're going to go over how floating points are actually interacting with the C language, and I'm going to let you know exactly what you see in each point along the way. It's going to be a fun one. Here we go. So in the last lesson, we talked about the printf statement, and when we printf something that's of a floating value, we start off by having a float value to work with. In this case, we're going to declare it into a variable. So we have a float value called weight, and this weight value is the container that's actually holding the value of 5.0 in it. So we invented a brand new variable called weight. We put 5.0 in it, and now 5.0 is the weight that we have to work with. In the next statement, we're actually printing that out to the screen. So we want to print out to the screen a sentence using that value. So the sentence is going to say, the current weight is %f grams. Now %f won't really show up on the screen, as you know. It's just a placeholder. So think of it as a fill in the blank in this sentence. So it has the current weight is blank grams, and that blank grams is going to come from the variable that's after the comma. So the variable after comma in this case is weight. So it goes to find what's the value of weight. It sees up here that the value of weight is 5.0. So it's going to grab 5.0 and use that in place of the %f. So now this fill in the blank value is filled in with the value of weight, and 5.0 shows in this position. But not exactly 5.0. I'll explain. When this sentence actually prints out, what you're going to see on the screen is exactly this. The current weight is 5.000000 grams. You might be thinking, where did all those zeros come from? I'm going to explain why. Every time you use a %f, just like that plain %f, nothing else around it, the %f by default always forces 6 decimal places after the period. So after this period in the decimal value, you're going to have 6 decimal places, and the value will be filled in. If you have less than 6, it fill in zeros to fill up the 6 spaces every single time. So when we have %f grams with no additional numbers there, %f grams is going to make 5.000000, 6 positions after the decimal point every single time. So what if you didn't want 6 positions there? You wanted it to be shorter, maybe you wanted to look like 5.0 like there. Well, you have a few options. I'm going to show you how you can control exactly how decimal values appear. You're the programmer after all. You get to pick how it shows. So let me show you your options. So in this example here, we have a numeric value in the %f. Now let's start at the very top. We have the same exact variable, float weight equals 5.0. We saw that in the last slide. And now in the statement it says the current weight is %4f grams \n and weight. So this is going to print out similarly to the last example, but there's one thing different, and that's that it has a 4 there in that position. Now the interesting thing, the way that it works, is that the 4 says that we want to have at least 4 digits or more in this position. Now, since 4 is less than the 6 decimal places that it wants to show, 4 is less than the additional 2 places that come with the period and the digits. If you have a number that's smaller than what the actual length is altogether, so this is how many different positions are we taking up by this number. We have 1, 2, 3, 4, 5, 6, 7, 8. So we count the period, we count the whole numbers, and we have 8 positions total. So it says by default we want to show 8. And if 8 is more than whatever number you put in here, then we're going to do 8. The higher number wins. So I'm formatting here says, hey, try to keep it to 4 digits. And you think it would listen to you and put it at 4 digits. But no, what it actually says is that I think I need at least 8 spaces for my number, so I'm going to take all 8. The numerical value here is a suggested amount that's either that number or greater. The system decided that greater was the right choice. And it's always going to do that every time it has its preferred way of showing it and what you are asking from it. Now what if you had a number bigger than 8? So now I have a 12 in there. I said, okay, go ahead and show me the numerical value with 12 positions. Now something that you may not have expected. So we talked about how many digits we had altogether. We had 8. This is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 positions for the number. But you said that you wanted to take up 12 positions. So it figured, oh wait, we gotta fill in 8, 9, 10, 11, 12. We gotta fill in 4 more spots. So what does it want to fill it in with? Oddly enough, spaces. So it went ahead right here in the front and it put 4 empty spaces. So when you put %12F, it says grab the number with the float, get 12 spaces, and then put that number left aligned so that I have 4 blank spaces, the whole number, period, and the 6 blanks. So it insists still on doing it 6 zeros at the end. It always wants to do the 6 zeros unless you give it a decimal place float position. We haven't yet. We have a whole number as a float position, and when you have a whole number, it's going to count the entire thing, and if it's greater than the number that you put in, then it's going to show the exact entire thing the way it has it. If it's less than the number that you asked for, then it's going to put extra spaces at the very right of the number to make sure that it uses up the entire space you wanted. Might be a little confusing. I'm going to go over it just one more time. When you have a number that's smaller than the entire length of the default viewing of a float, default viewing of a float is always 6 decimal places. So we have 1, 2, 3, 4, 5, 6, 7, 8. It's taking up 8 spaces to show this floating point number. If you put a number here and say, please show it in 4 spaces, it says no. The 8 that I think, the system thinks, should be shown is greater than your 4, so I'm ignoring your 4 and showing it 8 anyways. Now if you put a number that's greater than the size that it thinks it should be, it still thinks it should be 8 positions, the 6 zeros, the period, and the 5. It wants 8 positions, and you said, will you please show it in 12 positions? Then it's going to show those 8 positions left justified, and then fill in with blank spaces in the front, as many spaces as it needs to get to your number. So we had 8 to begin with. 1, 2, 3, 4, 5, 6, 7, 8. I'm using 8 spaces so far, but it wants 12 spaces to be taken up. So after the 8, it had 9, 10, 11, 12. 4 additional blank spaces to the left of the number. So we still kind of stuck with these 6 zeros at the end. What do we do if we want to get rid of those 6 zeros? Let me show you how. So in this case here, I have the same exact declaration, float weight, just like the previous examples. I have a print statement with the same wording, just like the previous examples. But look at what's in the %F. In between the % and the F, I have a 0.4. I have a decimal value. It's not a whole number 4 like the first example. It's not a whole number like the 12. It is 0.4, so it's 40th of a whole number. So this is a fraction now. 0.4 is a decimal value that I am giving before the F. So when I'm showing a decimal before the number, that means, hey, after this decimal, I have a 4 here, and that tells you that after the decimal, I want you to show only 4 spaces. So in this case here, the number was 5.0, and I said after the decimal point, show me 4 spaces with the numbers. So after decimal places, I only have 4 zeros. So it listens here to how many spaces you want to have after the decimal point. We only told it we had 1 at the very beginning, but when we displayed it inside the printf, we told it 0.4f. So that way it's going to say after the decimal place, I want to have 4 digits. And that's exactly what's shown here. So the current way that it's shown is 5.0000. That's the way that 5 is shown when you have %.f, 0.4f as the actual position point determinator. So what if we actually had a weight that was 6 digits long? We know all the floats could have up to 6 digits at the very end. That's the longest number of decimal places allowed for a float value. So if I did have a long number like this, 5.356716, well, it has now 6 decimal places to work with. So let's see how we want to print that. We want to print F, and we say, okay, I still want you after the decimal point to only show me 4 digits. That's it. I don't want the 6. I only want 4 digits after that decimal point. So then down here, I have my number 5.3567. If you compare with the original, you see that it did keep only 4 digits after the decimal place. And that last 16 was kind of just thrown off. I only have 5.3567. And so now I'm showing my number with the 4 digits after the decimal point. Now, we didn't really throw off the 16. We did something a little bit more complicated. I'm going to show you another example. So in this case, after the 7, I have 96 as the digits. And what it's actually doing is it's looking at the 4 digits, 3, 5, 6, 7, and before it actually chops it off at 4 positions long, at this example I still have 0.4f, it looks at the next number. We only want 4. It looks at the next number, the 5th one, and says, is this 5 or greater? If it's 5 or greater, then it adds 1 before it chops it off. So it does rounding up in this case. 5.3568 is what's going to show in this case here. We told it only show me 4 decimal places, and it looked at the 4 decimal places and then said, okay, what's after it? Do I need to round up or down? And 5 and up means round up. 1, 2, 3, and 4 means round down. So if I look at the example again, before and after, in the previous slide, I had a 1 after the 4 decimal places. I had a 1, so I'm going to round down, meaning I'm going to just leave the 7 as the digit. So 3, 5, 6, 7. But in the next example, I had a 9 after the 7, so now it knows it's going to round up. If the digit after the one that's going to, the last one to display is 5 or greater, it's going to round up. If it's 1, 2, 3, or 4, it's going to just stay the same, which is round down. So here is our new value, 0.4f, comes out with 5.3568, and that's what you will see on my screen. Because I said I wanted 4 digits after the decimal place, and it figured out if it's rounding up or down. So you get to pick how you want your numbers to show. You get to pick how many digits after the decimal place, and you get to pick exactly how it's presented within the sentence. So here's another example, and now we have a combination of the 2 theories. I say, okay, I want it to be, I have 5.0 again as my value, so 5.0 is what's inside of the variable weight. And I say the current weight is percent 12.4f. So 12.4f is going to do something peculiar to the number. First of all, it's going to make sure that the entire length is 12 positions. Please take up 12 spaces total. That after it allocates 12 spaces, it's going to figure out how much of that is going to be used by the actual number. So after the decimal point, I only want 4 numbers to show up after the decimal point. So it goes ahead and creates a number here. After the decimal point, and make sure that it has only 4 zeros, because I said 0.4 here, so 4 digits appear after the decimal place. And so how many days have we used up so far? 1, 2, 3, 4, 5, 6. We have 6 spaces that we've used up so far. And I said I wanted it to use up 12 spaces. So in between here, I have now 6 extra spaces just to fill in the blank. So the actual sentence looks like this. The current weight is space, 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 5.0000. So after the word is, I have 12 spaces total because I have the number 12 here. This first number before the period is how many spaces to use up, and the next number after the period is how many numerical digits should be after the decimal point. And that's how you control exactly how you want your numbers to look every single time. A quick review: when you have %f by itself, %F by itself is gonna always assume you want 6 digits to show. You have no numbers there, you didn't tell it how big you want it, so it assumes I'm gonna do it my way, and C has 6-digit precision on all floating values. If you have a whole number, no periods in there, just the 4 whole number, then the 4 means the total amount of spaces that's gonna use up. And so if the number that it wants to show is bigger than the 4, it's going to grow to as needed. So it's 4 or more. If I have 0.4, then 0.4 means after the period, after the decimal place, only have 4 digits. If you have less, it's going to fill it with 0 to make sure there's 4 digits after the decimal place. And 3.2 is an example of a case where I'm saying take up 3 spaces total and make sure 2 of them are used after the decimal places. So 3 is the total spaces that I need, and it's going to use 3 or more. And I'm going to say I want 2 characters after the decimal point. So with the combination of all these, you can go ahead and figure out how you want your numbers to look. And then make your program look exactly like you designed. You're the coder after all. Thank you so much, and I look forward to seeing you in the next video.